Better try, huh?
Yeah. This,
So don't over grease it.
this, if you're going to put a lube on it, it's going to be a very light spray, like a Teflon spray. And what I'll do is I'll spray it on and then I'll wipe it off with my hands, so it leaves a coating, but it's not pooled.
But we don't want to overlube that and deactivate primers.
I'm told by my customers that, by a couple of my customers, that using WD-40 will cause your inert primers. It doesn't even have to soak the primers, the vapor. One of my guys said he stored primers where he was using WD-40 and it made them inert. So I'd shy away from that. I don't know that to be a fact, but that's what I've been told.
Yeah, it does.
Oh yeah, I believe it.
Yeah, it does.
You can put, again, that bearing grease on the back of this pusher and this pusher over here.
Just a little dab.
Yep. Light spray on the bullet slide bar. Again, wipe it off with your hands. Powder slide bar's got to be a dry lubricant, motor mica, or I use this is motor mica. That's what I use, or you can use graphite.
Well, doesn't the powder itself kind of keep most of that lube?
The powder you don't want to work back there. You don't want to use that because that also is an abrasive. That's why one of the reasons why you don't want to use any type of a liquid lube. That, plus it'll cake the powder, you won't get a good drop. But graphite or motor mica. If I remember, I will include some motor mica with the package. I had one of my customers locally who sold his business years ago and gave me a 5-gallon bucket of it. So I will include some with the machine. And if I forget, call me and say, hey, idiot, send me some, will you? What else do we have? That's about it back here. There's really not much to lube. On the shuttle bar, you'll do the same thing, a light spray. Wipe it off with your hands. Again, everything runs a little bit better, more dry than wet. Okay. Okay, I'm going to put that in there so I don't lose it. I'm going to disconnect the vacuum pump. We have some cords we can leave. I don't know where those came from. We're going to move that off to the side. I'm going to put the machine back over here. Okay, I think that's it. That's your 45 sizing die. We won't be using that. Okay, just watch yourself. I don't want to hit anybody with anything. Okay. I believe, I just want to take one look. I think I can cycle the machine. There's nothing in the way. What's happening is the upper plate's coming down. You see our roller is on the radius of this cam. So it's holding that shuttle bar in location with the dies concentric to the cases. Once we push that shuttle bar all the way out, which is right there, then we can start bringing the shuttle bar to the left. Once we reach the full left position, we'll know where it is when this roller comes off the cam. Okay? We've just taken over with the left-hand stop that's up there. Okay? That should occur just before the bottom of the stroke, about 1/8 to 1/4 of an inch before the bottom of the stroke. Okay? The reason for that is, especially when you're sizing, but with all the dies, you want that machine still moving down when the shuttle bar snaps in. If the machine is already started up and the shuttle bar is not in, there's nothing holding those cases down. Okay? In some of the dies we have pressure down, seating a bullet in that. But you want that shuttle bar in before the upper plate starts up. So about 1/8 to 1/4 of an inch before the bottom of the stroke. Okay, we reach the bottom of the stroke. That's where most of the functions are performed. Okay, now we're starting to get the upper plate out of the way. The case is free of the dies, and then we can start driving it over to the left. And then we're back to the top of the stroke again. You didn't see it, but at the bottom of the stroke, this bumper pin, and let me go through the cycle so you can see it rather than explain it. And coming to the bottom of the stroke, if you watch this pivot arm, it's going to seat. Okay, I just didn't see it move. Okay, I was thinking, why isn't it seating? But it is, yeah, I didn't see it move. Right now we're starting to flex that pivot arm, starting to move it. We're pushing the primer seating pin up. It's up. Okay, we seated the primer to depth, we've probed the primer pocket, and now it retracts. It's only moving about 1/8 of an inch. The thickness of the primer slide where the primer is only 119 to 120 thousandths thick. So we're only moving that dimension. That reaches flush with the bottom of the case, and then 3 to 5 thousandths deep, wherever you like to seat your primers. So we're only moving about 125 thousandths. Okay? And then we're at the top of the stroke.
Okay, now when we were talking about replacing the cam, this is what gets replaced?
No.
Oh.
It's under here.
Oh, okay.
We would take this screw out, and you can tap that holder. Let me pull it off just so you see what's there. It's not a big deal, but it's nice to see.
If you're going to replace the cam anyway.
Yes, I will replace the cam. Okay, that's turned down to 1 inch. When we can drive that up for that 1/8 of an inch or the difference in the case length, put a shim underneath and pull it back down onto the shim.
Okay, or you said change the cam.
Or we're going to change the cam. We'll do that when we flip the machine back.
Okay. Oh, so we have to change the cam for 45 anyway.
That's right.
Okay, I got it.
Now, if I'm not mistaken, is a 45 the same length as a 10 millimeter?
Ooh,
because you can use your 45
close.
cam.
Damn close.
And
because a 45 and a 10 fit in the same magazine.
This isn't
the
exact measurement. I mean, if there's only 10 thousandths, 15 thousandths difference, we can make it work.
Okay.
You've got that much clearance in the screw that's holding that cam in place.
Overall case length or overall cartridge length?
Case.
Okay.
Looking for the 40? 45.
1.25. No, it's a complete. It's OAL.
Okay, guesses. What do we think? 0.898 for 45, 0.992 for. So you got
100 thousandths.
Not even. 898 to 992. 4 thousandths.
8992?
No.
No, I'm sorry. Oh, no, you're
998.
right. Yeah, 998. I was 992 and 898. So that'd be
almost 100 thousandths.
Yeah,
6 thousandths short.
Yeah.
Or 6 thousandths long of 100 thousandths.
Yeah.
No, short.
No, actually, it's right on. Because it would be 2 would take you to 9. 2 thousandths would take you to 0.9. So you got 0.0.